Alright, I'm Ethan Harvey, and this is Quideo 3, Stats Quideo 3 basic question. Alright, Rotner Partners is planning a major investment. The amount of profit X is uncertain, but a probabilistic estimate gives the following distribution in millions of dollars, and then it gives us this table of the profit and the probability that that'll be the profit. So, question A says, find the mean profit and the standard deviation of the profit. Alright, for the mean profit, we just have a pretty simple formula here. All you have to do is multiply the profit by the probability that'll be that profit, so 1 times 0.1 and 1.5 times 0.2. And it's basically this top value by this bottom value. And then you add all those together, which will give you mean, which is in this case is 3. Alright, and then the next part is for standard deviation. This is a little more complicated, but basically we're just going to square the profit, and we're just going to multiply it by the probability, and you'll get all these values, which will give you this. And then you take the mean squared, which we found up here, and subtract them. So 15.35, which is all these added, minus the mean squared, and that'll give you 6.35, and that's the variance. And to get standard deviation from variance, all you have to do is square root the variance, because standard deviation squared is equal to variance, and that will give you 2.52 as the standard deviation. Alright, part B. Rotner Partners owes its source of capital a fee of $200,000 plus 10% of the profits X. So the firm actually retains. This is the formula for how much money they actually make from the investment. Find the mean and standard deviation of Y. Alright, for mean, we're just going to do the exact same thing. So we're going to plug the profit into this and then multiply by the profitability. So you can see I did that here, add up all the values again, it gives you 2.59 as the mean. Alright, and for standard deviation, we're going to do the same thing as before, except this time we're going to use the new mean that we just found instead of the old one from question A. And that'll give you 8.64, again, square root that. This is because this is the variance to give you standard deviation, and it is 2.94. Alright, this is AP Statistics Quideo 3 Advanced Question. An insurance company estimates that it should make an annual profit of $150 on each homeowner's policy written, with a standard deviation of $6,000. Question A asks, what reasons may contribute to such a large standard deviation? Alright, so the reason that there is such a large standard deviation is because the insurance company will pay most people no money, because a lot of people don't get into very many accidents, and that's how they make their profit. But there's very few people who do actually need their insurance money when something happens to their house. In this case, they'll pay a lot of money out to them so that they can fix their houses. So this is just the reason there's going to be such a big standard deviation, is because there's such a big difference between most people who won't get paid anything or very little, and the people who are going to get paid a lot. So that difference just contributes. Alright, and question B asks, if it writes only two of these policies, what is the mean and standard deviation of the annual profit? Alright, so mean for this is really easy. You just multiply the mean times the amount of policies written, so 150 times 2 is 300. And for standard deviation, we're going to use variance again. So remember, standard deviation is the square root of variance. So we're going to square both of these standard deviations, because the rule that there's a rule that the standard deviation squared and then plus the other one, square root of that, is equal to the standard deviation of both. So we're just going to apply that here, and you can see that we get about $8,485 as the standard deviation. Alright, and for C, it says if it writes 10,000 of these policies, what are the mean and standard deviation of the annual profit? So we're just going to do the exact same thing as before, except we're changing the amount of policies written. So 150 times 10,000 gives you 1,500,000. And then for standard deviation, we're going to do the same thing. 6,000 squared times 10,000, which is the amount of policies, and we're going to get this, it was 600,000. And for D, is the company likely to be profitable? Explain. So we're to find out if it's profitable, obviously anything above $0 is a profit. So we take 0 as the example, and then we can find the z-score of it. So 0 minus the mean, which is 1,500,000. And over 600,000 for the standard deviation, that'll give you a z-score of negative 2.5. And if we use this table here, we can see that negative 2.5 correlates to 0.0062. Multiply that by 100, that's 0.62%. So that's the chance that the insurance company will not profit off of an account. So if we take 100 minus 0.62, that means 99.38% of the accounts are going to be profitable for this company. So that's a very high percentage, and this company is very likely to be profitable. Alright, this is Stats Quideo number 3, an AP question. When a tractor pulls a plow through an agricultural field, the energy needed to pull that plow is called the draft. The draft is affected by environmental conditions such as soil type, terrain, and moisture. A study was conducted to determine whether a newly developed hitch would be able to reduce draft compared to the standard hitch. A hitch is used to connect the plow to the tractor. 2 large plots of land were used in the study. It was randomly determined which plot was to be plowed using the standard hitch. As the tractor plowed the plot, a measurement device on the tractor automatically recorded the draft at 25 randomly selected plots in the point. After the plot was plowed, the hitch was changed from standard one to the new one, a process that takes a substantial amount of time. The second plot was plowed using the new hitch. 25 measurements of the draft were also recorded at the selected points in this plot. Alright. Question A. What was the response variable in this study? So, response variable is just what's being measured, so that's the draft, that's what they're measuring in this. And the treatments, that's the different things that are done to the experimental units. So that's the old hitch and the new hitch, that's like what they changed. And the experimental units, that's just what is receiving the treatment, so that's the 2 plots of land. Alright, and for question B, given that the goal of this study is to determine whether a newly developed hitch reduces draft compared to the standard hitch, was randomization used properly? So yes, we back up here, it said that they randomized which plot was being plowed by which tractor with which hitch. So that was good randomization, and they did select it randomly, so yes. And for C, given that the goal of this study was to determine whether a newly developed hitch reduces draft compared to a standard hitch, was replication used properly in the study? And for that, that is no, because they only plowed 1 field with each type of hitch. So there's a good chance that the differences in the actual fields is going to cause like the measurements and not the actual hitch change. So they should have done it with more fields. Okay, plot of land is confounding variable in this experiment. Explain why. So that's basically what I just said. Because they only plowed 1 plot of land with each hitch, we don't know if it's the environmental factors in that plot that led to the data. Because remember up here, it said that the draft is affected by environmental conditions such as soil type, terrain, and moisture. And it's not very likely that the plots had the exact same composition of soil. So the differences in these plots is going to lead to differences in measurements. What they should have done is they should have done multiple plots with each type of hitch and then averaged and compared the results, but they didn't do that. So that's why plot of land is a confounding variable.